Hello guys, welcome back to the channel. Today we want to solve exam style questions on indices and surds. It's one of the topics that almost every year we see it in our examinations. So we want to take a look at it. Now we start with this particular question, but before we even get right into it, please note that in the description I've linked both the question papers and the marking scheme. All right, so download both so that when you work it out, you check with the marking scheme whether you are correct or wrong. All right, let's start with the first question. It says that without using a calculator, express root 5 minus 3 all squared over root 5 plus 1 in the form p root 5 plus q. Okay, so until you get it in this form, we are not done working the question out. All right, so let's start. We have this root 5, okay, minus 3 all square over root 5 plus 1. So when you have a surd dividing by a surd, basically what you want to do is to remove the surd in the denominator, and that is what we call in mathematics, that huge name, rationalization. So basically what we are doing is we are rationalizing it. So what you do is you take the opposite of the denominator, and that's what you multiply through by. So the denominator is x root 5 plus 1, so we multiply through by root 5 minus 1. That's the opposite of it, and that's what we call the conjugate. Okay, the conjugate of it. All right, now you just multiply it out. But before I do that, I'll first expand the numerator. Okay, that will give me 5, okay, minus 6 root 5 plus 9, I believe so. All right, and then I have root 5 plus 1 times root 5 minus 1 root 5 minus 1. Okay, now I will simplify. That means that I have 14 minus 6 root 5 over root 5 plus 1 times root 5 minus 1 root 5 minus 1. Okay, all right, then what we now do is that we use the 14 to multiply through this. We use this to multiply through that. Okay, so we have 14 root 5, and then we have negative 14, then we have negative 6 into 5, then we have plus 6 root 5 all over. Now the denominator, I can see that is difference of two squares, so that's just basically 5 minus 1. All right, so in the numerator, what we are going to have is we have, check this now, negative 14 minus 30, so that's negative 44 if I'm not mistaken. And then we have plus, what we do have here is 14 root 5 plus 6 root 5. That should give us 20 root 5, right? And the denominator is 4. Now if you divide through by 4 throughout, you can also factor 4 out in the numerator and then cancel out with the denominator 4. That will be negative 11 plus 5 root 5. All right, so if you don't like it this way, you can also write it this way: 5 root 5 minus 11. Once you get your answer in this form, you stop, because it correlates with what they wanted you to do. So P is 5 and Q is negative 11. All right, so that's how to solve a set like this. Now the next thing that we want to look at, okay, now this worksheet has a lot of questions, just that I'm taking some questions out for us to solve, and then the rest you do it. So we have this indices that we want to apply all the rules of indices to give it a try. Okay, so it says that given that this is true, we should find the values of A, B, and C. Okay, so first let's get root P, and then Q R to the power negative 2, over P square Q to the power 1/3 and R, okay? Now, what they want us to do is to, work with this. Now, the numerator has to be 1, so we want to take everything down there. Well, just note that root P is the same as P to the power half, and then the QR, or the power to the power -2, also means Q to the power -2, R to the power -2, okay? Then we have divided by, we have P square, Q 1/3, and then R. Now remember that in indices, when numbers are, dividing, we just subtract the powers if the bases are the same, right? Okay, so that means that for the P, what we do have will become P half minus 2. Then let's go to the Q. Q, we have Q -2 minus 1/3. For the R, we have -2 minus 1. So 0.5, okay, that's half. 0.5 minus 2 is -3/2. So this is P -3/2. Then for the Q, what we have is -2 minus 1/3. Calculator tells me that's -7/3. And then for the R, we have -3. Okay. Right. Now, note that when you have a power that is negative, it basically means 1 over P to the power 3/2. And then this will be 1 over Q to the power 7/3. And this will be 1 over Q to the power 3. All right. Since they are all multiplying now, we can conclude that our answer is 1. The numerators will multiply, which is still 1. Now we have P to the power 3/2, Q to the power 7/3, and then R to the power Q, like that. Now, this is directly in line with what they wanted us to get. Okay? So you can see that A is 3/2, B is 7/3, R is 3. Okay, so this is you applying the laws of indices to this particular problem. All right, now the same question, okay, or a similar one is here. Let's give it a try. We have P R square all to the power 3/2, and then we have root QR all over Q square P R square to the power -1. Now we can expand the first one, so we have P to the power 3/2, and then R square to the power 3/2. Then when you see root QR, that means that it's QR all to the power half. Every square root is to the power half. Okay. Now the denominator, we have Q square, and then we have P to the power -1, and then we have R square all to the power -1. So we have P 3/2, then we have the R. This 2 will cancel out with these 2, so we are left with R cube. And then for this particular one, this half affects both the Q and the R. So we get Q to the power half, R to the power half. Now let's come to the denominator. We have Q to the power square, okay, 2, and then we have P to the power -1. Now on the R, this multiplies that, giving us -2. Okay, now the next thing we do is to apply the division rule that says that you subtract the powers, okay? So for the P, I have P to the power 3/2 minus, well, the P here is -1, so be careful. So you have minus into brackets -1. Then we have, next one is Q, right? Good. So the Q is here having a power of half minus the Q down there having a power of 2. Followed by QPR, so R. Well, before we do anything, I want you to take a look at these two R's. You have R here, you have R there. If the bases are the same and they are multiplying, you add the powers. So first we have 3 plus half, okay, that is 7 over 2. Then we go down there. The r here is negative, so we have minus, but that r is negative too. Be careful with these things. They are, reasons for you to get it wrong. Okay, so be careful. So let's deal with the first one. We have 3 over 2. Minus 1 means plus 1. That will give us 5 over 2. Then we have q, which is 0.5 minus 2. That is negative 3 over 2. Then r is 7 over 2. Okay, 7 over 2 plus 2. And that will be 11 over 2. Okay, so now you have represented it nicely in the way they wanted you to get it. So you are done with the 3 marks. It says that using substitution, y is equal to 2x, we should solve this. They are saying, or otherwise, that means that if you think you have a better idea, use it. Okay, but I don't think I'm going to use any better idea here. I'm just going to use what they give me. So I have 2 to the power 2x plus 1 minus 2x plus 1 minus 2x plus 1 equals 0. Okay, so now this means 2 to the power 2x. The plus 1 means there's a 2 multiplying it. Remember, indices, this power 1. So since the bases are the same, you add the powers. That's how come they got this particular power. Same thing as this. Okay, now I'm told that wherever I see 2x, I should just put y there. Okay, so now this 2x here means that you let me split it small, okay, for you to see what's going to happen. This 2x all to the power squared, right? Then times 2. And you have this 2, you have that, you have plus 1 equals 0. Okay, so if I put y there, then I'm going to get y squared, okay, but times this 2. So I'm going to get 2y squared. And if I put y in place of this, I'm going to get minus 2y. Okay, and then if I put y here, I'm going to get just negative y. And then I'm going to have my plus 1 equals 0. Therefore, I have this 3y plus 1 equal to 0. Okay, now from here, it's a quadratic that we need to solve. I would just go and try and see if I can use the calculator to do it, but in the exam, you can't. You can't do that. You have to show working, okay? For one thing, I'm not in the exam room. I'm just a YouTuber, so I can use calculator to solve it. I have y equals 1, and I have y equals half. But I'm not done. But because they gave me the question in terms of x, okay? Everything here is x. So you have to say, but 2x, okay, is equal to y. Well, that means that our first answer, we have 2x is equal to 1, because that's what the first y is. So, how would you get 1 though? Basically, it means you can write the 1 as 2 to the power 0. Okay, so you can say, or you have this as 2 to the power 0. And that means that x is 0. Because if you compare the bases and the powers, x must be 0. Now, the next thing is you have 2 to the power x is equal to half. But what is half? Half is the same as you saying that 2 to the power negative 1. So that means that x is equal to negative 1. So your two answers that you are looking for are x equals 0 and then x equals negative 1 for your 4 marks, obviously. Okay, now let's look at this question. It says that the point, this, okay, lies on this curve. Well, that English really means that if I put the x value, okay, this is the x value, okay, into where I find x, then the answer I will get should be the y value. And the y value in this case is p, because, I mean, that's what it is. So let's solve it and see how that goes. So we are just basically doing a substitution. Wherever you see y, put p there, so I can say p is equal to, all right, then I'll write 10 plus 2 root 5 all over x squared, right? But what is x? It's 1 minus root 5 all squared. Okay, so first, expand the denominator. You need to do that. Like the trick I showed you, do this. The first term square, so that is 1. The next thing you do is you multiply them out. 1 times negative root 5, that gives you negative root 5, times 2, you have negative 2 root 5. Then finally, you have negative root 5 all squared, that's basically 5. Well, if we're in doubt, this is what I want you to do. Expand this thing out, really. And I believe you get the same answer, okay? It's something which is emphatical, it's true. All right, so that means we have 10 plus 2 root 5 all over 6 plus 2, 6 minus 2 root 5. Now at this stage, you want to rationalize your workout. So you use the conjugate, right? The opposite of the denominator, all right? And then you'll be fine. Now let's multiply out the conjugate. So first I'll use this 10 to multiply everything here. So that will give me 60, all right, plus 20 root 5. Then I'm going to use this 2 root 5 to multiply everything out here. So I'm going to get 12 root 5. That means 6 multiplies 2. All right, then plus I have 4 into 5. Why? Because here the 2 multiplies the 2 and the root 5 multiplies root 5, giving me 5. Now divided by the denominator. The denominator is basically difference of 2 squares, because it's plus, you have minus and plus. So I'm going to square the first number, that is 36, minus the square of the second number, that's 4 into 5. So that means that basically I'm looking at, let's do the top one first. We have 60, okay, for here, 60 plus 20, giving us 80. Then we have 20 plus 12, that's 32. So you have 32 root 5. All over, this should be 16, right? Because you have 36 minus 20, yeah, that's 16. Now, how do we proceed from here? You see, if you look at 80 and then 16 and then 32, I believe that there is a common scenario here. Can we factor out 16? Can 16 go into 80? You can just try 80 divided by 16, and that gives me 5. So that means that 16 can go there. So I know I have 16 into bracket 5 plus. Now this 32, if I remove 16, I'm left with 2 there, and then I have root 5. Root 5. Okay, all over 16. So this and that will cancel out. That leaves me with this answer. Okay, because that's what they wanted me to get P. All right, they said the exact value. I should simplify my answer. That's why I went through all these necessary steps. Okay, now you don't put it on a calculator, you leave it here, because that is the exact value. All right. Well, the next thing that we want to do is to solve this particular question, the question 4. Okay, so the question 4 says that solve the equation this. Well, I haven't really taken a deeper look at it. Maybe it could be, indices problem, or it could be logarithm. If it's a logarithm, then I'm going to just solve it in the logarithmic way. I have a video on that on the channel. But if it's indices, then we're just going to do it in the indices, okay? Now, if I look at 9 and 27, I know that these are some powers of 3, so I'm okay with it. But I'm left with the 2, 4, 3. So let me do 3 to the power 4. That is 81. So I'm going to do 3 to the power 5. Yes, so that's 3 to the power 5. So this is an indices problem. The 9 becomes 3 to the power 2, right? But you have 5x there, so keep it like that. And then the 27 is basically 3 to the power 3. But you have x minus 2 there, so keep it like that. And then this is 3 to the power 5. Okay, let's continue. Now we have 3 to the power 10x. You have to multiply that out. And this we have 3 to the power 3x minus 6. And then you have 3 to the power 5. That's cool. The next thing I want to do, it's up to you basically. You can decide to use this to multiply that, or you can just divide this, guys. Whatever it is fine. You let me just go with the division. So I have 3 to the power 10x minus, okay, everything that is here. So minus 3x minus 6 here is equal to 3 to the power 5. So this would become minus 3x plus 6. Okay. Then the next thing that I do is simplify. I get 7x plus 6 is equal to 3 to the power 5. So now, since the bases are the same, we equate the powers. So we have 7x, okay, plus 6 equals 5. So 7x is equal to negative 1, right? Yeah. So x is equal to negative 1 over 7. I believe so. Have we made a mistake? I don't think so. Okay. That's for question 4. Let's look at question 5. That should be probably our last question for the day, you know. And no, I'll solve one more question, then we end it here. So if we have this, I believe, no, in fact, I will not solve this question 5 because we've solved several examples in this form. So let's rather, give this one a try. I mean, then end our discussion because it's been like 30 minutes now. So we have this shape there. It says it shows what trapezium, blah blah blah. This angle at D is 90. I mean, they have given us a lot of instructions, but what do they really want? We should find the perimeter of the trapezium. Now, if you want the perimeter of the trapezium, then that basically means that you need to find your BC, right? Because that is what we need. If we don't know the BC, we cannot find the perimeter. Why? Because we have this, we have that. All that we are left with is BC. And if we know BC, then we are done with the question. Okay. Now, so how do we proceed from here? Let me clean these things here. I want you to take a look at this. A trapezium is just, this particular trapezium is what we call the right-angled trapezium because it has a right-angled triangle in there. So I can divide it like this, and you can clearly see that we have a rectangle and then a right-angled triangle. Now, once we have a rectangle, that means that we can use Pythagoras theorem to find BC. Okay, now this part is also going to be 7 plus root 5, no doubt, right? All right, the next thing I want you to do is to note that, all right, from here, all the way to here is 4 plus 3 root 5. So we are left with finding what this is. So we just have to subtract it from 11 plus that. So we have 11 plus 2 root 5 minus 4 plus 3 root 5. So that would be 11, okay, 11 minus 4, and that would be 7. And then we have, check this thing out, 2 root 5 minus 3 root 5, and that's basically negative root 5. So that's the base. 7 minus this. Pythagoras theorem. So now let's find out BC. BC, you know what? Let me do the workout here and then just go and put it down there. So BC square is equal to 7 plus root 5 square plus 7 minus root 5 square. Okay, then let's expand. So that will give us 49 plus 14 root 5 plus 5. Now this one will also be 49 minus 14 root 5 plus 5. Now check this thing out. This and that will cancel out. Okay, then you have 49. So we have this 49 plus 49. So 49 plus 49. Then you have plus 5 plus 5, so that's plus 10. So we are looking at 108. 108. Then we have, we don't have any Surd there. So we are basically done. So that's 108. So this guy is 108. Okay, so now let's copy this friend of ours. We'll put it down there. Okay, so we can even clean this guy. Okay, so now the perimeter is basically going to be, let's see. Let me check this now. Have we left something now? How come we didn't get any said? Anyways, it doesn't matter. So that's BC squared. It's not just BC, it's BC squared. So that means that BC must be equal to the square root of 108, okay? And square root of 108 is 6 root 3. Okay, so let me just clean this guy and put 6 root 3 there. So we are now going to add things up. This plus this plus this plus that. That is the perimeter. So we have 4 plus 3 root 5 plus 7 plus root 5 plus 11 plus 2 root 5, then plus 6 root 3. So now, let's add the numbers. We have 4 plus 7, then we have 11. That's it, right? So that should be about 22. Then for the root 5, we have 3 here, and we have 1 there, making 4. So we have, and then, sorry, making 4, because it's 3, 1 here, making 4, and then this, making 6, right? So 6 root 5. Then we have the last one. There's no other root 3, so we just keep it there. So let's take this guy down there. So that's what the perimeter is. Can we squeeze it small? Yeah, so that it fits into here. So that is our perimeter. Okay. Now they said that find the area of the trapezium. Well, area of a trapezium area is half into brackets a plus b times h. What is the a plus b? They are the parallel sides. So let's go and do the workout up there and bring it here. So half times the sum of the parallel sides. So that's the sum of this and the sum of that. So that is 4 plus 3 root 5 plus 11 plus 2 root 5. All right, times the height. What's the height? 7 plus root 5. This is the height. So we have half. Now in the bracket, we are going to have 15 plus 5 root 5. Then this is going to be this. Okay, now we can take this down there and then further work on it. Okay, now if we want to go with our argument, I'm thinking of a better way. I think we should just multiply it out first, so that we have 15 times 7. You forget about the half for now. We'll use it later. So 15 times 7. 15 times 7. That will give us 105. And then plus 15 root 5. Okay. Then now I'm just going to use this to also multiply this now. That's going to give me 35, right? 35 root 5. Plus, I have 5 into bracket 5. Okay, so I have my half there. The bracket, within the bracket, I'm going to have 105 plus 25, giving me 130. Okay, then I'm going to have 15 plus 35. That is giving me 50. 50 root 5. So at this stage, I can now multiply 3 by the half. So 130 divided by 2 is 65. And then 50 divided by 2 is 25. So basically, this is the area of the shape. Okay. So this is where we end. Like I said, I'll put the worksheet in the description. You should take a look at it. And then I've also added a marking scheme. So download both, solve, and compare your answers with the marking scheme. Until we meet again, take care of yourselves. Bye for now.